We use technology called LIBS, laser-induced breakdown spectroscopy. We use a laser to heat the soil. It's a pulse laser. It heats the soil to about 10,000 degrees. At that temperature, the molecules break down, and we can measure the spectrum, the spectral signature, and that tells us exactly what elements are present. This is a process that exists in labs, but we are innovating by bringing it to the field. There's two ways to use our device. The first one we're coming up is something that you put behind a tractor and you drive it through the field. So imagine that ATV, right, but just having our piece of equipment and you're dragging it through the field and you're measuring it. So it's very similar to what they would do today, and people that are measuring soil today would be able to transition to this new way of doing it in a more accurate, faster way. We have a second step, which is even more interesting, which is to integrate it into an operation that the farmer is already doing, like planting or tilling or doing something else in the field, so that you don't even need to go and drive the field for measuring. You can be measuring as you're planting. Farmers today would typically drive in an ATV to a certain point in the field and take core samples. So they would stop the ATV in a certain location using GPS and take typically 8 samples. They put them each in a bucket, they mix them, put them in a bag, label the bag, ship it to the lab. A week later, they get the results. They do that across the entire field. Very time-consuming, very costly. So what is missing and what we're solving is a nice, practical, convenient, fast way of doing that. And not only doing the same what they're doing, but doing a better job, because we can measure more nutrients, we can measure faster and get results in milliseconds. Best case scenario, a farmer that is doing this correctly today would measure a point every about 100 meters, 330 feet. So the issue with that is that soil changes much faster. Soil changes about, not every 330 feet, but changes about every 60 to 80 feet. So there's a lot of variability, and that is not captured by the current method. And we can do it conveniently, and we can do it with high resolution.
So if you have a more granular kind of set of data, you can more accurately, understand what's going on and then apply the appropriate levels of inputs.
Yes, so the idea is that knowing how much nutrients are in each piece of the field, you can apply for that piece of the field the exact nutrients you need. It might be that you're fine in nitrogen, but you're low in phosphorus, so you apply phosphorus only. If you don't have that information, you would be having to guess and apply a flat rate, and it's going to be wasteful. It has several downsides. It's costly, and it's also can lead to runoff. So this is a much better way of doing it. And if you can do it in high resolution, then every single piece of the land can have the right amount, which is what we want to do.
So you can kind of break up the field into smaller kind of lots, if you like, and then have that more accurate, targeted application.
Correct.
How actionable is this more granular information?
Yeah, that's a great question. Most application equipment that is used to apply the fertilizers is either 60 foot or 90 foot. So it's that would be the typical width. What makes sense is to measure at that same resolution. If you measure more granular than that, you won't have really a good way of acting on it.
You've described kind of real-time nutrient mapping as the holy grail. How close are you to a system that can measure nutrients, say at the front end of a machine, and then adjust fertilizer application immediately behind it?
Yeah, we're actually quite close. We are starting with the nutrients that are not very mobile, phosphorus, potassium, lime. For those, you have the time, so you can measure and you can apply later. That has a lot of advantages because farmers can order their material and know how much they're going to use and pre-buy and have it delivered and then they apply it. But the second step, which is what you're talking about, is to measure and apply it. And that's super important for mobile nutrients. The main one is nitrogen.
Yes.
Sulfur is another very mobile nutrient. And for those, every time it rains, it changes and the concentrations in the field change. So it's very important to measure at the time that the plant is growing,
yes.
what is called in season. So if you can measure at the exact right time where the plant is uptaking,
yes.
you don't have to predict the weather and how
yes.
much, because you already are in the window.
Immediately.
Yeah,
yes.
you're applying it at the time that is being uptaken by the plant. So that's our next plan. We're probably going to release that product in 2028. In 2027 is when we're releasing the measure product for PK and lime. So we've verified that our system works and that it produces very accurate results, yes. and very high resolution results. And that's working really, really well. The next things that we're working on is making it so that it can go faster, and that entails making our equipment that goes through the soil slimmer. We have we call it a wedge that goes and creates a trench in the soil. Right now, it's a little bit wide. We want to make it less wide so that when you go through the field, it takes less power to move it, and it can move faster. It creates less soil disruption. We think that's going to be important for a good number of customers. Then the other part that we are still working on is in the UI, making the equipment very easy to use, so that not only our engineers can operate it, but eventually agronomists or even farmers can operate it.
How fast can you go before it loses its ability to work?
So we think that we can go really fast. We're at 5 miles per hour today. We have a clear path to get it to 10 miles per hour. We think that 20 miles per hour might be possible one day. With all the focus going to AI, some other areas, including AgTech, are not necessarily being sought as much as by investors. So I would characterize this as a challenging environment. But I can tell you that Blue River, we started funding just 1 year after the Great Recession, right? Big financial crisis. Raising money there was really complicated. I am of the thinking that when in this down cycles, it's sometimes where the biggest, best opportunities end up being funded, right? I think that investors that invested during those times were found valuations to be more reasonable and the returns to be higher.